Next, we'll add some spells. Prepare spells here, and we don't have the spell stuff yet, so we'll just set the spell power to 1. So let's get some input from the user and make the character walk. And we'll have to keep track of our old position and old location as part of our collision detection strategy. So first of all, we'll use a switch to determine how to animate the character, and we're going to be adjusting the walk speed. So let's just get the animation for walking, and we can make adjustments to it directly. So using that walk index that we recorded, so we don't have to look it up again, we set walk anim to point to our walking animation. So that's what it refers to. So we could have a idle 1 motion and idle 2. And what this does here, if it's idle 1 or idle 2, it's going to treat it in the same way. And I can use a timer to select which idle mode to use, whether it's going to be 1 or 2. 2 would be the blinking one. If the last hero motion wasn't motion.idle1 and last hero motion, and it's not equal to idle 2, then we can say reset the idle timer. So idle timer equals 0. And we'll do about 155. If it's less than or equal to, then we'll say hero motion is going to be motion.idle1. Otherwise, if the idle timer is greater than 155, which obviously it would be, you could just change this to an else. If the hero motion equals motion.idle1 and the hero, which is the animation player, check is animation done. So it finished doing a cycle of idle 1, then we're going to say you can go ahead and change the hero motion to motion.idle2. So if, for example, he's in the middle of a blink, you don't want to switch the animation halfway through the blink, which is what this line is about to be. If it's the blink animation and the animation is done its cycle, then we can switch it to 1. And in this case, we'll set the idle timer back to 0. Then it'll start all over again, timing the idle. So it goes from 0 to 155 and then 155 to whatever it takes to get to the end of the idle 2 animation, and then resets the timer. And let's make sure to update that timer with ++. And if we're in idle mode, the user may want to move in a direction. So if the key is down and it's keys.right, let's resolve this, because I don't want to have the entire scope showing like that. Then we'll say hero motion equals motion.walk, and since we're going right, we'll make sure that flip is set to false, and let's accelerate him in that direction. We could say 1, but we'll say 0.80, and just tweak it based on whatever seems to work the best for your game. And then left, same idea except flip would be true, and in this case we want to say minus equals. This should be plus equals positive. This should be minus equal. I don't know what I was doing there. And say the user presses the down arrow, then I just copied that whole line. Then the motion will be duck, and duck mode is going to start off as duck state.down, because that's the direction we want to animate him in. Otherwise, if the user is pressing up key, so they can press up or they can press space. And in this tutorial, I'm not going to get into mapping out the controls, but there are some patterns that you can use that can help you to map out your controls. I might get into that some other time. So if grounded, hero animation index, so ouch index. So if the user presses up or space, and so long as they're grounded or they've been injured, we're going to allow the character to jump. So on its own, normally you just say if grounded, hero jump. If they've been injured, I allow the user to jump just so they can escape whatever is attacking them, if it's an enemy character or if it's spikes. And if they push the control button, let's say control press rather than control down, or they push the alt button, and we'll call hero attack. So we'll have to create some functions to handle these. For now, I'll just comment those, and we'll focus on making them walk and duck. For the case where motion duck is being applied, click break here, and we'll have to set up another switch based on which duck mode it's in. In the case that the character is ducking down, hero.reverse equals false. So just resetting the reverse status for that animation in case it was in reverse mode. And it would be if he was starting to stand back up and then you push the down button again. If the down button is not being pressed, then we have to go back to standing up. So change the duck mode to duck state.up. And if the play direction is not in reverse, which it will need to be, we'll say if it's done the animation, meaning that it's right at the end of a cycle, then we have to reset it for starting in reverse. So in other words, you're pressing down to duck and you let go to start standing back up right at the very end of the animation cycle, which is a special case. So if that animation is done, but it's not playing in reverse, then we have to start it in reverse. Otherwise, it's simply a matter of saying meo hero reverse equals true. It's just telling it to play that animation in reverse from wherever it is. Break out of this. In the case of duck state.up, and I'll just label these real quick. Okay, I'm back. I just added a few more comments, and we'll label this one standing up. Since we're standing up, let's make sure reverse is true. So we're playing the reverse of the duck animation, and if the user is pressing the down arrow to start ducking again, partway through standing back up, then we're going to set it to duck state down again. And if the hero animation is done, then what we can do is say reverse is now false. The character has fully stood up, so it's going to change animations. And initially it's going to switch to motion.idle1, which is sort of like the home base, and other user inputs can override that. Okay, and so this is the closing bracket to switch for duck mode. We're still within the motion for duck. If they hit Control or Alt, we want it to do a hero attack. So we'll say if imp.roll down, Control press. And this way, if you're just starting a duck or ending a duck, you can hit the attack button and it'll respond quite quickly. So it won't finish showing the entire animation for ducking down or standing up in that case. Then we'd call hero attack. Now we don't have that yet, so I'll just comment that out for now. That should be everything for duck. We'll go to case for walking. While we're in walk mode, by default, it should reset to motion.idle1, and then we'll check to see if the player actually still wants to walk, and based on what direction they're pressing, it'll set what direction and the fact that they're walking still. If input key down, keys right, we'll say hero motion is motion.walk, and flip is false, because he's walking to the right. If the velocity isn't too big, and max velocity is a bit misleading. That's horizontal velocity, so I should probably have called it max x velocity, or actually made it a vector and say max velocity.x. Let's actually add a max velocity in here, and that could be a dynamic variable actually too, not necessarily a constant. Go up to the top of the class where constants are, and this doesn't have to be a constant. It could be dynamic. Maybe you get a power up that makes so that you can go faster. We'll just make it a constant for this particular game, about 7.3. Don't ask me how I came up with that number. We'll go back down here and we'll just copy this, change this to left. Flip is going to be true because he's going to be facing left, and we'll say negative max velocity minus equals. And what you could do, and it might even be advisable, is have a very small little method that just takes care of setting up like walk right and walk left and ensuring that it doesn't exceed the maximum velocity. But since it's pretty small and you can just copy and paste it, I think this is just as good, maybe better. It's just that if there was some sort of behavior that you needed to change, then you'd have to copy it and make sure you paste it into the other places. Right here, we don't worry about whether the velocity is exceeding max velocity because you're in idle mode. There's no way he would have gotten to that speed, so that should be fine the way it is. So when we're walking, we'll also want to be able to duck, in which case if input, key down, keys.down, and hero motion, just motion.duck. In duck mode, same as before, the start is duck state down, and that's to start ducking. Else, if the user presses up, or they press space, which is for jump. Oops, I'm missing a bracket here. So if they're not trying to duck, then if they're trying to jump, they need to be grounded to jump. We'll say hero, and we'll also include the scenario where they might have hit some spikes and you want them to be able to jump off them. So not necessarily grounded, but maybe they landed on an enemy character or some spikes. So we'll say ouch index. Allow them to jump to get away from the danger. And we don't have this yet, so I'll just comment that for now. Actually, I'll just do this. And we won't have this one yet either, so we'll just start it. We'll just copy this from this one up here. Here we're going to add the gravity to the player. and slow down the player's velocity. So if they let go of a direction, they'll just gradually slow down. Determine which direction they should be flipped based on whether they're facing left or right, and we'll move the player. Let's start by doing that. Vector 2, true velocity. So we could just say that true velocity is velocity, but we're going to factor in the rescale value because the character is a different size than it might normally be. And we'll say position plus equals the velocity. And before we set up the collisions, let's go down to set animation so that the appropriate animation will be put into play. So sometimes we don't want to allow our animation to switch. Normally we do, so we'll just say allow switch. When we don't, it would be if must finish animation. Let's say if the animation isn't done, then we'll say allow switch is false because we haven't finished animating. But if it did finish, then we'll say that must finish animation is no longer true, and hero motion set to motion.idle1. So it finished the animation. For this loop, we'll just leave it as not allowing the switch yet because it may need to determine something else first. So if allow switch and last hero motion is not equal to the current hero motion, so only if the animation has actually changed and we're allowing a change of animation, then we'll switch the animation to its new animation. So based on the current desired hero motion, the one we'd like to change it to, if it's idle 1, then we'll set the animation to idle 1. And this is using the dictionary to look it up, which uses a hash table, which is fairly efficient. So we'll put in some cases. We're going to have an idle 2, walk, duck, jump, ouch, and spell. We'll just set those here based on what the animation names were in your animator. And one thing we mustn't forget is we just changed the animation, so we want to make sure that we notify that the animation is changed, and this is what the last animation was. So now last hero motion and hero motion are not going to match, and then up here it's going to know that the animation was changed. The last animation is not equal to the current desired animation, for example. And then too, when it gets here next time, it's going to know that the two animations, the current animation and the last animation, are the same, so it'll know not to switch the animation to starting one of these new animations. Our set animation is actually kind of acting like our update too for the animation system. We'll set the hero position to be the screen position, so now the animation player is going to play that animation at the actual game player's screen position. And we'll call the update method, passing along game time if we need to use it, and that updates the animation of the character. Now let's go into our draw method here so we can actually see what the character is doing. Using our quad batch, because we need distortable vertices, applying the character's texture, and in some cases that texture map may have multiple character informations on it. And we'll use alpha blend for pre-multiplied alpha. And the default hero color is set to color.white, so fully opaque and the full value of all the colors in the RGBA channels. In the case that the character is invincible, we can play with the color a little bit. So based on, so we'll be counting down from say like 100 or something. So we'll set n to be invincible, modulus 10, and we'll say if n is greater than 5, then the hero color is going to be more of a red, so it kind of indicates a flashing reddish shade. We could also use alpha on there too, but I wouldn't do that with an animated meomotion character because the parts are overlapping, so we'll just tint it sort of red. So the R value is completely 255. The green and blue values are lower at 155. Alpha is still full. That's flashing with invincible. Really the only thing we need to do here to draw the character is say hero.draw and whatever the hero color is. Usually it would be white. In this case invincible can modify it. And the other thing we draw in here is any of the spells. So we'll show spells here, but we'll do that later. If you build your project and test it out and you get something like system DLL not found exception in monogame.framework.dll, that means that I believe since I started the project using a version 3.5 template and I've migrated to 3.6, the template probably put in some DLLs that we're not getting right now. So I'll just have to look that up and add them in where they need to be, and then we'll get back. Go back into the player class and at the bottom add a quadbatch.n end, because otherwise it's going to keep calling begin and it's going to return because begin was already called. You can go up to game 1 and construct, and just make sure you set the initial screen width and height to be exactly the current display mode's width and height dimensions. And go back over to the player class, and it's important that we set the screen position of the character. So I had this here, and we forgot to do that, so it's not going to draw it in the correct place if the screen position isn't set. And this just converts the world position so that we can have the screen's position for the character. You might notice on the right side here under Solution Explorer, things are kind of looking different. There's extra files in here. I had to convert over from the 3.5 build of monogame to the 3.6, so there have been quite a few changes. But all I had to do was make a backup copy of the folder and then start a new project using the new template, and then just copy everything into this one and build it, and it seems to work fine. So let's test out what we got so far. As you can see, you got the regular idle animation as well as the blink animation, which occurs every so often. And his walking speed doesn't match his motion speed yet, so we'll have to fix that first. And I'm just adding a new folder here, default, so I can kind of clean up some of this stuff. Hopefully it doesn't break anything. There, a little less to look at in here. See if it still builds. Yep. Yeah, it works fine. If we wanted to, we could change these icons. Looks like we got a larger version here, smaller version. We'll have to make sure too we got a compatible version of the BMP so that we got our transparencies correct if we're going to do that. Okay, go into the player class, and we'll work on adjusting the player's animation speed based on how fast he's walking. So right after slow down player and set animation play speed, we'll type in if the velocity is greater than 0, and we're going to reduce the velocity by 0.4, and if the velocity becomes less than 0, we'll just set it to 0. We'll set the direction he's facing as to the right. And this is where we adjust the walk animation speed. So since we have direct access to this walk animation, which we made up here, walk anim equals referring directly to the walk animation with the index that we saved, we can just say walk anim.speed is equal to velocity.x times 42%. I got that number from a little bit of guesswork and a little bit of testing. So just copy this line, do the same thing for if it's less than 0, and we'll add to the velocity. If it becomes greater than 0, we'll set the velocity to 0, and we'll say the direction is left, and we'll say the walk animation speed is the velocity times negative 0.42, because we need a positive animation speed, and the velocity is going to be negative because he's going left. And now that we have the direction that he's facing, we can say if direction equals facing dot right. And keep in mind that the velocity won't necessarily dictate what direction he's facing. He could have been knocked back. There's a lot of different things that can happen. So if he's facing right, we'll say that the animation does not need to be flipped. But if he is facing the other way, to the left, we'll say flip is true. While we're in here, we may as well make a note that we're going to update spells in here. Oh yeah, and since the player gets hurt and then becomes invincible for a little while, we have to make sure to count down that invincible value. And we'll make the function for ouch in just a second. We'll just go to the top of the updater here, and there may be times where we need to adjust the play speed of the animation, like the general play speed, and that could happen if we're underwater or whatever. So we'll just set it to 1 here, so it always resets it back to its default. Anytime it detects though that you're in water or whatever, it might change that animation play speed in the meantime. This just resets it so that if you're out of water, you don't have to say the animation speed is set to 1 because you're out of the water. So just testing out the walk animation, which now adapts, and you can see that the camera smoothly pans to catch up to the player. So that all works fine. So I'm in the editor now. I'm just going to go ahead and create a quick little test level, and then that way we can test out our collision detections a little more accurately. So if I hit these keys, I can just put whatever blocks down that I want. Backspace to erase. All the instructions are in the top left-hand corner there. We can offset things using the numpad arrows. and rotate with the less than greater than sign. Right now I have it rotating at the corner. It'd probably be handier if I had it rotate from the middle. And we can minus plus to scale it. You have to be over the actual tile location that you placed it at. We can hit the F12 key and we can see where those tiles are, or at least we can see where the solid tiles are. And we could put in an optional too so that we can see the occupying locations for each tile too. So this one only occupies this one tile here, and I gotta be over just the right one right here. So I have to be over this one to adjust this. The advantage of it only occupying one tile is we can put other things in front of it, like a flower or something. Then we can change the layer depth of these items too, using page up and page down. So if I want this over the player, I can hit page up and he'll go behind it. If we ever mess up our level and we really need to load from the backup, we can hit the asterisk key. But normally we'd hit the exclamation mark to load from content-lev.1.txt. Since we haven't made one yet, it won't let us do that. When we want to save it, we'll hit the $sign and it'll show us the time saved to confirm that it actually saved the file. If we need to modify colliders, we can hit the insert key to add colliders. Backspace, just delete. And if we really messed up a tile, we don't really like what we did with it, we can reset that too using the home key. And just press enter when you want to test the level. Just remember that when you've made a level, it'll be in the content folder for the executable section. So any CPU debug, and it'll be in the content. And so when you make your release version, you'll need to copy that and go to release and go into the content folder that will be here after you generate it, and then paste it in there. And the same sort of thing applies for your wizzy.txt file or whatever you're calling it. So your meomotion animation file. Right now we just got it alongside the platformer in the debug version. Okay, so I made this test level, and now we just need to create a collision system, and then we can turn on our gravity and add the jump and all that stuff. We'll first start off by figuring out what tile the player is occupying. Location.x, which is the map location, is going to be the world position divided by 64 because each tile is 64 by 64. And we do the same thing for y. And I could use a conversion method, but there's a little less overhead. Just putting this right in here, it's small anyway. And just so we don't have to keep saying loc.x, loc.y, I'm going to say x is equal to loc.x and y is equal to loc, just for the purpose of the collision detection section. So let's first make sure that we're within the bounds of the map so we don't do anything silly. Prevent illegal memory access. If x is greater than or equal to the map's tiles wide, or the x value minus 1 is less than 0, or the y value plus 1 greater than or equal to map tiles high. And finally, if y minus 1 is less than 0, we cannot investigate tile locations that are off the map. So those are out of bounds, so we'll have to restrict ourselves within the bounds using the old position and old location. Oh, we've got an extra bracket in here, we don't need that. The position will equal to the old position because we can't be at this position, it's out of bounds, and we're going to set the location to the old location so that we're within the bounds. That's just a way of preventing it from crashing if we try to access stuff that's out of bounds. A precaution. Shouldn't happen though. So we'll get the movement vector. Part of the reason it shouldn't happen is we have that border that's automatically generated around it, as long as the collision detection system is working properly. We'll get our movement vector, our position minus our old position, and we're assuming that the velocity never exceeds the size of a tile, 64 by 64, but that's extremely fast. Like Sonic the Hedgehog doesn't even go that fast, so we're not going to worry about that. If you did need to worry about it, you can use a sweeping test through multiple tiles. So bounce velocity is going to be max jump minus 8f. And that's how fast you'll jump up if you hit one of the spring platforms. And that'll come in handy for the next section here, which is moving up. Of course, it could come in handy for the other ones too if you land on it from above. And we're also going to have moving down moving right, moving left, and hit spikes. And we don't want to use else ifs for any of this stuff because there are scenarios where you're doing more than one thing at once. I would say the same thing is true. I see people making the mistake in their user input where the user may be able to do multiple things at once and they're saying else if, else if, else if, and I try to avoid that if I can because the user may want to do a jumping punch and they hit both precisely the same time and it's not happening. Moving down would be if move.y is greater than 0. Moving right, move.x is greater than 0. Less than 0 to go left. We'll do moving down last, actually. So we'll pull this out because we want the right and left to adjust before we do moving down. The easiest one to take care of is going to be moving right and left. So let's check tile to the right and see if it's solid. And if the position.x plus half the player's width, so we'll have to make a variable for half player width. We'll just take a measurement of the player and I'll add this variable. Okay, I just paused the video and checked the player dimensions, and I'm going to say that the half player width is going to be 32. Player's feet, I'll say offset, be 26. And player's head offset is going to be 51. And those are the distances from the root bone because his position is at the root bone, so it's in the hips. And that's where you got to measure these distances from. So down to the feet's 26 pixels and up to the around the top of the head is 51. So that would be below the tips of the ears, close to the top of his head. I'm not counting the ears because this is for the purpose of collisions. We know the player's moving right and there's a solid to the right. So if the position plus half the player width is going to be greater than that x plus 1 tile location times 64, so in terms of world coordinates, is it going to be greater than the left side of that tile is what we're asking. We'd say position.x is equal to, if it will be, and we'll set position back to the old position and make sure the X is updated to the old location. That way when we do our tests for the rest of the collision detections, it'll all be accurate. And we can copy this and put it in moving left. Let's change this to -1 and say minus half the player width because it's from the root bone. And if it's less than, not x plus 1, but x minus 1 plus 1, which is x, because we're looking at the x minus 1 here, plus 1 because we want the right side, so it's just x times 64. And we do the same sort of thing. We prohibit him from moving any further by setting him to the old position. Now technically, he doesn't actually exist at this position yet. This is just the recorded position. This is the position that we're requesting. If we're moving high velocity and we wanted him to hit right on the edge of whatever he's colliding with, then we'd actually adjust his position based on the vector distance from that edge. But since his speeds never get that high, we don't really have to worry about that. So let's test out what we got so far. So you'll notice that his legs can't go through, but his head can. So we'll have to test for the tile above it too, because he occupies 2 tiles. We'll say else if tiles x plus 1, y minus 1 that is solid. In other words, only if we have to check this, we'll check it. Same sort of thing. This else if is in the wrong spot here. It should be on the outside of this one. And we can copy this into here. And we'll do the same sort of thing for the left side. Say else if tiles x minus 1, y minus 1, solid, and do the same thing. Now let's test it out. Okay, can't go through that with his head, so that seems to be working.